started. Here's the. Okay, where did we leave off of? We were doing part of the solving fraction story problems, right? Let's go ahead and continue that. Okay. So we're just going through, this locked us out, so we're going to just go through the, I think you're almost done with this tutorial, Victor, and then we can move on to the next one. All right. Huh? What? These already. Oh yeah. Good. Oh yeah, we did this one. So next we're gonna go ahead and did you want to go? Let's go ahead and try to do the other one first. Let's see. We have recognized proposition and relationships. So, did you feel comfortable? You want to do the tutorial or the mastery test? M then A then T. M A mastery. M A S then T then pull back. Go ahead. E then, R then, next letter is, with eyes, I. So, Victor, I noticed, so I'm just going to go ahead and remind you, so your elbow has to be pulled back. So every time you pull a letter, go ahead and pull back, okay? So let's practice. Spell baby. B then, pull back. A then, B, okay, hold on, let's try. Actually, let me do it with the stencil. Because that's what I need to be working on right now. Okay. Oh, where's your poker? I don't see it. Oh, here it is. Okay, so I'm going to start working on it. We don't want to do the laminate. So we're not there yet. There you go. All right. Okay, so let's go ahead and do intentional motor exercises for now. Go ahead and do poke letter A. Pull back. So we're going to start pulling back because I noticed that you're looking with this instead of your eyes. We need to start using our eyes instead of the poker. Okay, so it's a clean spelling. Go ahead and spell cold. C then pull back. Good. O then pull back. Next letter is L then D then. Good. That was good. Cold. Yeah. Okay, let's try one more time. Read. Go for it. Or go get it. Go for it. Get your next letter. Look. R then. E then. Next letter is A then. Next letter is D. Very nice. Okay, that was a good pullback. Okay, so I'm just gonna keep reminding you until we get it like clean cut spelling. Okay, go ahead and spell test. Go. Find your next letter. Look. T then pull back. E then pull back. Go. Get it. S then. And next letter is go. Get it. Pull back. Look with your eyes before you poke. Look with your eyes and poke. T. Very good. That must be better. Okay, let's try one more time. Let's do solve.
Sure.
Solve. So first letter is S then pull back. Put your elbow. Solve. Go next letter is O then pull back. Pause. Go ahead. L then pull back. Go. Next letter is get your eyes to it. Down. V then pull back. And next letter is go. E then pull back. Okay, solve. That's it. How about close? C then elbow. Good. Nice bow back. L then pull back. Go. Get it. Go. Get to it. O then. Next letter is S then pull back. E then pull back. Nice. Okay. All right. We can go ahead and move forward. Okay. All right. So let's go ahead and do 2 tutorials and then we can do the test afterwards with those ones. Okay. All right, so let's go from here. So recognizing proportions and proportional relationships. You said you want to do the mastery test. Are you is that your final? Are you sure? Because last time we didn't go through the mastery test and we got a lot of them wrong. So it's always okay to review. So go ahead though. Let me know. Do you want to go through you want to go ahead and go directly through the mastery test? Yes or no? Go. Find your next letter and then. Oh, okay. So your option is we can go through the tutorial. Would you like to go through the tutorial? Go. Next letter is first letter is Y then. E then. Yes. Very good, Victor. Okay. All right. So here's the tutorial, right? Recognizing proportional relationships. Okay. Let's go ahead and do that.
Recognizing proportional
I don't want him to talk. I want me, right? Objective. In this lesson, you will decide whether two quantities are in the proportional relationship. Okay. Introduction. Proportional relationships are part of our daily lives, especially in activities such as cooking, which is what we're doing, shopping, which is what we are also doing, and banking, which we did way in the past, right, when we first started. Two quantities are said to have a proportional relationship if their ratios are equivalent. For instance, chefs use proportional relationships in recipes so that each serving is the same. Right? Each serving is the same. No matter how many servings they make, if two quantities are proportional and you know one quantity, then you can find the other. By knowing the unit price of a product, for example, you can find the total cost for any number of units. In this lesson, you'll look for proportional relationships in tables and graphs. This is tables and this is graphs. Proportional relationships. Two quantities are proportional if they maintain an equivalent ratio. They take a look at an example of a proportional relationship. Jenna is baking oatmeal raisin cookies. The recipe calls for half a cup of raisins. So, half a cup of raisins. Half a cup of raisins. Where did it go? Okay, so two quantities are proportional. Okay, Jenna is baking oatmeal raisin cookies. The recipe calls for half a cup of raisins of a batch of 12. So there's going to be half a cup of raisins for a batch of 12, right? Batch of 12 cookies. Okay, half cup of raisins. Okay. Jenna can bake more than 12 cookies if she proportionally increases the amount of every ingredient. We'll focus on the raisins. The table shows different amounts of raisins and the corresponding numbers of cookies Jenna can bake. The ratio of the first pair of values in the table is 1/2, right? So 1/2, which is what they have, and divided by 12 because there's 12 in a batch, right? This is the ratio of the number of cups of raisins to the number of cookies. The ratio of the second pair of values is 1/24. Okay, so let's show the proportional relationship between the number of cups of raisins and the number of cookies that Jenna can prepare. To do that, we'll prove that all ratios of the pairs in the table are equivalent. Remember that any number times 1 is equal to the number itself. We can apply this idea to numbers that are expressed as ratios, even when those ratios contain fractions. First, let's show that the second ratio on the table is 1/24. 1/24, right? To get to 1/2/24 is equal to what? 1/4. Okay. Okay. So semicolon, 1/4 times an equivalent of 1 equals 1.5 divided by 12. To get from the ratio 124 to the ratio 1.5 over 12, we can multiply the number of 1 over 24 multiplied by, right? 1 over 24 multiplied by 1/2. So this is 1/2. Okay? This is, and you want to multiply it by 1/2. Okay? As the denominator, we also need to multiply the denominator of 1 over 24 by 1.5. Or by 1.5. Okay? Which is where we're at. The fraction equivalent to 1 that has only 1/2 as the numerator has also a 1/2 as denominator. So as we see, so we also need to multiply the denominator of 1 over 24 by 1.5. So as you can see, it's 1 over 24 times 1/2 by 1.5, right? Half by 1.5 equals 1/2 divided by 12. Okay, where we were able to convert the ratio from the other by multiplying by a form of 1. That means the two ratios 1 over 24 equals and 1/2 over 12 are equivalent. Okay.
Let's show the proportional relationship between the number.
Next, let's see if the third ratio on the table is equivalent to the first ratio. The third ratio is 1 and 1/2. 1 and 1/2. My eraser. Oh, there it is. So, for this one, it says, okay, so cups and, let's see here, where are we at? We covered the ratio 3 and, so, okay, I'm sorry. So we got 1, let's see, the third ratio is 1 and 1/2, right? 1 1/2 over 36. Or 3 2 over 36. Okay, the first ratio of the and the first ratio is 1/2 over 12. 1/2 over 12. Okay. To check whether they are equivalent, find the fraction equivalent of 1 that can multiply by 3 and 2, 3/4 and 2, divided by 36. By 30 is to get 1.5. 1.5 divided by 12 times 3 2s over 36, right? To get the ratio of 3/2 to the over 36 to the ratio 1/2 over 12, multiply the number of 3/2 by 36 by 1/3. 1/3. The fraction equivalent of 1 that has 1/3 as the numerator also has 1/3 as the denominator. So we will multiply the denominator by 1/3 as well. Excuse me. All right. 1/3 as well. Okay, so we got 3.5 by 36 times by 1/3 over 1/3 equals 1/2 over 12. We converted the ratio from 3 2 to over 36 to 1/2 over 12 by multiplying by form of 1. That means the first and third ratio in the table are equivalent. Okay. because the first, second ratio are equivalent and the first and third ratio are equivalent, it follows that all three ratios in the table are equivalent. 1/2 over 12 equals 1/4. 3.5 by 30, and then equals 3.5 by 36. The number of cups of raisins and the number of cookies in Jana's recipe have a proportional relationship. Okay. Next, let's study another example to see whether a proportional relationship exists. Leslie baked carrot muffins and apple muffins for school event. Oh, sorry. Excuse me. Ooh. School event. She made 5 more carrot muffins than apple muffins in each batch she baked. The table shows the numbers of carrot muffins and apples muffins in each 3 batches. So, in the first batch, the number of muffins, apple muffins are 10, right? 10 over, and then the number of carrot muffins is 10, and then over 15. Okay, all right. In the second batch, so 10 over 15. This is batch 1. Batch 2 is number of apple muffins equals 15, right? That's batch 2 right here, Victor. And then over 20, okay, which is over 20. 15 over 20. Okay. The relationship between the number of apple muffins and the number of carrot muffins is proportional only if the ratio of the number of muffins from each batch are equivalent. Let's talk whether the ratio of the number of apples muffins to the number of carrot muffins in the second batch is equivalent to the ratio in the first batch. As before, we look for a fraction equivalent of 1 that we can multiply 5 by 15 to get 10 out of 15. Okay? To get from the ratio 15 out of 20 to the ratio 10 out of 15, multiply the numerator of 15/20 by 2/3. I mean, the fraction equivalent of 1 that has 2/3 as the numerator also has 2/3 as the denominator. We will also multiply the denominator. Notice that multiplying the numerator and denominator of 15 over 20 by 2/3, right, gives us what? You got 10 over 40 over 3. Not 10 out of 15. There's no fraction equivalent of 1 that we can multiply by 15 out of 20 to get 10 out of 15. So that's not a proportional. Okay? So the ratio of 10/15 and 15/20 are not equivalent. So the numbers of apple muffins and carrot muffins in the table do not have a proportional relationship. Okay? Recognizing proportional relationships from tables. As you can see, proportional relationships are often displayed. Oh my goodness, sorry, Victor. Excuse me for yawning. If you are given a displayed on a table, if you are given a table with pairs of values for 2 quantities, you can calculate the ratio of each pair. If the ratio are equivalent, you know the 2 quantities have a proportional relationship. To apply these ideas, read about Tim and his upcoming purchase. Tim wants to buy several pairs of jeans. He compares the prices at the store in his neighborhood. And at the online store, he finds that pair of jeans cost $24 at the local store. Okay? $24. Alright? If he buys online, the pair would cost $22 plus shipping. $22 plus shipping online. So this is local and this is online. Okay, and it would be 22 plus 6, which is 28, right? Okay. In the following theory, you will determine whether the number of pairs of jeans Tim combines and number of purchases have proportional relationship. Okay. See my phone. Let's see here. Okay, so directions. Read the instructions for this self-checked activity. Type in your work response for each question and check your answers. At the end of the activity, write a evaluation of your work. Okay. In this activity, you will identify proportional relationships found in tables. Tim wants to buy several pairs of jeans. Okay. He compares the prices at a store in his neighborhood and at an online store. He finds that a pair of jeans costs $24 at a local store. Each pair would cost, but if he buys online, each pair would cost $22 plus shipping and handling equals $6, so that would be $28. Right. Complete the tables to relate the number of pairs of jeans to the cost of the jeans at each store. Assume that Tim is placing a single order and ignore my taxes. Okay. So here you got how many pairs of jeans do they have on the local store? How many pair? So we would be let me see, where's your numbers? Oh, you didn't pack your numbers? Okay. So which one is it? How many pairs of jeans do we have in the local store? 2 and get it. Next number is 24. 24. All right, let's go ahead and put that in. Okay. All right. And on the let's see here. Okay. One jeans and then two jeans. It says 2 jeans equals $48, and then for the first one, a pair of jeans is equals $28. So what is 2 pairs of jeans would cost? What would that be? For 2 pairs of jeans, what would it cost on an online store? Go. 5 and 2. 52. Think about it. Hold on. No, 1 second. 52. Are you sure? Is that your final answer? Oh, is that your final answer? Yes or no? Oops, sorry. Is that your final answer? No. So, if 1 pair costs $28, how much would the 2 pairs cost? Five and 6. 56. Okay. Let's check on the other one. So 56 plus 28 equals what? So yeah, 56. So 3. I'm sorry. Well done. Oh, your car's coming. Hold on. So for this one, 2. Yep. So that makes sense. So this one 24, 48, right? And then what would be the third one for a local store? What would it be? Go. 7 and 2. 72. Okay. 5 minutes. Your car will arrive in 5 minutes. Okay. So let's go ahead and add this up. And that is correct. Okay, good job. All right, local store. Here, I had an example answer. So pairs of jeans, 28. So that's what you have. And then online store, 28. At the local store, the cost of 1 pair of jeans is $24, and the cost of 3 pairs of pairs is 24 times 3 equals 72. At At the online store, the low cost of 2 pair jeans is 22 times 2, right? Plus $6 equals $50 for the second pair. Okay? And the cost of 3 pairs is 22 times 3. Plus the shipping equals 72. Okay? Okay, alright, so 72. So, in here it says, look at the table that represents the local store. For each row in the table, find the ratio of the number of pairs of jeans to the cost of the jeans. So the local store, you got, what is the ratio of the first for one pair in the local store? Go for it. 1N divided by, go, 2 then, 4. 124, okay? So let's do that. 1 divided by 4, okay? And then let's go ahead and put that submit. Very good. That is the correct answer. In the second row, the ratio is 2 over 48, which simplifies 1 over 24, right? In the third row, the ratio is 3 over 72, which simplifies 124. Next, look at the table that represents, look at this car, make sure we don't miss it. Where are we here? Oh. 1 second. It's grabbing me your info. So right now, where is it at? 3 minutes pickup. So we can go ahead and keep going for 2 more minutes, okay? So for this one, are the ratios that you calculated in part B equivalent? Are they equivalent in B? Yes or no? Go for it. Are they equivalent? Y then, E then, S. Okay. Based on these ratios, what can you conclude about the relationship between the number of pairs of jeans that Tim buys at the local store and the cost? Okay, so here it says, what can you conclude about the relationship between the number of pairs of jeans that Tim buys at cost? Okay, so go ahead. What can you conclude? I then, next letter is, go backward. And it's super close, right? I then, posture please. I then, go. T then, next letter is, go. Get it. Get your eyes to it. Look. S then, it's, or ITS, or what else? It's, or, okay, ITS, what is next letter? Okay, think about your next. So it says, the question is, based on these ratios, what can you conclude about the relationship between the number of pairs of jeans that Tim buys at the local store and the cost? So, go for it. I then, T then, go, find your next letter. I then, S then, it is. A then, next letter is, go. A then, next letter is. A then, R then. A then, R then, next letter is, go. F then, R. Okay, hold on a second. Let me write this down. It is. It is. So you said it is. What else? What is it? What do you conclude about it? What are the about this ratio? It is. R then, A then, T then, I then, O then. It is ratio. Okay, I'm gonna go ahead and type that in there. Is there anything else you'd like to add with that? No? All right. Oh, okay. Let's see if we got the right here. Oh, he's here. So let's go ahead and shut this down. All right, stop